Hey, what's up, guys? We're going to talk about the Pythagorean Converse today and see what that does, how it can help us out. So first thing is, what the heck is a converse? Okay, converse is a statement switches the if and then parts of it. So for example, if we said if a triangle has 3 equal sides, it's equilateral. The converse says if a triangle is equilateral, then it has 3 sides. Okay, so just flipping those if-then statements. If a number is even, it's divisible by 2. If a number is divisible by 2, then it is even, right? So that's what a converse is. It's just flipping that statement. So with triangles, we know that if a triangle is a right triangle, then a squared plus b squared equals c squared. So the converse of that would be if a squared plus b squared equals c squared, then the triangle is a right triangle. Okay, so today we're going to be using the converse to prove whether or not triangles are right triangles. Do they have that 90 degree? Okay, because sometimes they might look like they are, but we now are mathematicians and we can prove whether they are or not. Okay, so this is what this looks like. We're looking at these triangles. We might look and we're like, that might be a right angle that I'm looking at, but we need to prove it for sure. So I see my longest side, that's the hypotenuse, and then I have my legs. But the converse says a squared plus b squared equals c squared. If this is true, when I plug in these numbers, then this is a right triangle. If it's not true, then it's not a right triangle, right? So we're going to have 84 squared plus 13 squared. Remember, a and b could be either order, but your hypotenuse has to be the longest side. Okay, 85 squared. So we just need to know, is that a true statement? So I'm just going to hop into Desmos here. So 84 squared plus 13 squared is 7,225. And then 85 squared is also 7,225. That means this is a right triangle. Okay, the two sides equal each other. This is true. So this is a right triangle. That's what the converse does. It tells me, hey, I can prove that it is, not just relying on what it looks like, but actually using mathematics to prove it now. Okay, so again, it looks like this would be my right angle. So we're going to prove it. My longest side is the hypotenuse, the other two are the legs. So a squared plus b squared equals c squared. So this time we have 15 squared plus 12 squared. Does that equal 21 squared? Okay, so 15 squared, 12 squared, 21 squared. So 15 squared plus 12 squared is 369. 21 squared is 441. So that's not a right triangle because 369 does not equal 441. Slashing that equal sign tells us that it's not equal. So no, this is not a right triangle, because for it to be a right triangle, Pythagorean theorem should be true. Okay? That's all we're doing, is proving that measurements are or are not a right triangle. So now I don't have the picture. I have 16, 9, and 11, and I want to prove, would those make a right triangle if we connect them? So longest side is the hypotenuse, and then the other two sides would be the legs. Okay, so a squared plus b squared plus c squared, equals c squared. Okay, let me make sure that looks like equal, not equal. All right, so we plug in, and I always write the formula because it tells my brain, oh yeah, what do I plug in? So a, I said, is 9, so 9 squared plus b is 11 squared. Does that equal 16 squared? Okay, and again, you just hop into Desmos. 9 squared plus 11 squared is 202. does that equal 16 squared? 256. So no, this does not work because 202 does not equal 256. So this is not a right triangle. Okay, so do it again. 20, 29, 21. First thing is, which are my legs? Which is the hypotenuse? Hypotenuse is the longest side. So my other ones are the legs. A squared plus b squared equals c squared. Okay, so we have 20 squared plus 21 squared. Does that equal 29 squared? So we go 20, 21, and 29. Okay, equals 841. 29 squared is 841. Hey, these equal the same thing. Okay, so this would be a right triangle. We could use those lengths to make a right triangle. Okay, using the converse, if a triangle is a right triangle, a squared plus b squared equals c squared has to be true. Okay, all right. Patty wants a triangular garden in her backyard for all of her vegetables. She's going to use 3 pieces of fencing that measure 7 feet, 10 feet, and 8 feet. Will her garden be in the shape of a right triangle? All right, so my longest side would be 10. I'm just going to draw myself a picture here. Right, so if it's a right triangle, it looks something like this. Right, it would be a 90-degree angle. So we're trying to figure out, is that true? So we would do, sorry, let me write my formula first. A squared plus b squared equals c squared. So I have 7 squared plus 8 squared equals the hypotenuse squared, so 10 squared, right? 49 plus 64, okay, we can go to Desmos. That's 113. Hopefully you know what 10 squared is 100, okay? So 113 does not equal 100, so this is not a right triangle. And our proof is this right here, because the Pythagorean theorem doesn't work. It's not a true statement. So that's what using the converse of the Pythagorean theorem is. Just, I should be able to take the lengths given. It should make the equation true. If it does, hey, it's a right triangle. If it doesn't, no, it's not a right triangle.